Potassium chlorate warmed up to the melting point, a gummy, a shield. Potassium chlorate, KClO3, is an oxidizer. In grade 9, we learned that oxidizers can give oxygen to combustible materials. In this case, liquid potassium chlorate gives a combustible sugar in the gum a dose of highly concentrated oxygen. Combustion reactants. When an organic is in the presence of oxygen, it has the potential to burn. Here is a bottle of ethanol. Here is a blue jug full of air which contains oxygen. A lot of students say, why can't you do that twice? And this is why. Nothing happens. Why? If there is an adequate amount of oxygen available for a complete burn, the only products will be carbon dioxide and water vapor. I would guarantee there is still ethanol inside of the bottle. But since all the oxygen was used and had been turned to carbon dioxide and water, there is no oxygen to react with the ethanol that's in the bottle. Combustion reactions always involve an organic reacting with oxygen. The result is always the formation of carbon dioxide and water. When we are given these questions, after we've identified that it is combustion because we see an organic reacting with oxygen to make carbon dioxide and water, we want to take those words, switch them into formulas, and then balance. So I will have to dissect 2-butanol to find out what is inside of that molecule. But means 4 C's, so I draw 4 C's on the side of my piece of paper. Ane means singly bonded. All means I have an OH and it goes on the second carbon. So I count my carbons, and on the second one, I place an OH. Now I fill in the rest of carbon's bonding potentials with hydrogen. So 3 hydrogens added to the first carbon, second carbon needs 1 hydrogen, third carbon needs 2, and the last carbon requires 3. And then I just add up everything that is there. I've got 4 carbons, 10 hydrogens, and 1 O in my picture. So 2-butanol is C4H10O. It's reacting with oxygen, a diatomic. So I write O2. And that turns into carbon dioxide, which is a covalent molecule. So it says just carbon, which is 1 C, and dioxide, which is 2 oxygen. So CO2, 1 carbon, 2 oxygen. And it also produces water. Now I have to balance. I put a 1 in front of the most complex formula, which would be C4H10O. I don't want to balance the oxygens from the get-go because oxygen is everywhere. But if I see that carbon is only located in one spot on the left and one spot on the right. So that means they're going to have to balance. And when I put a 1 in front of C4H10O, that gave me 4 C's. So that means I will need 4 C's on the other side of the equation. So I will put a 4 in front of the carbon dioxide, which will give me then 4 carbons and 8 oxygen. Next, I can balance the hydrogen because hydrogen is only located on one spot, in one spot on the left-hand side and one spot on the right-hand side. So in the 2-butanol, I have 10 hydrogens. So that means I will need 10 hydrogens coming from the water. So I place a 5 in front of the H2O. And now hydrogen is balanced. Now I deal with that oxygen, which is again located everywhere. So in the 2-butanol, C4H10O, I have 1 oxygen. On the right-hand side, in the carbon dioxide, I have 8 oxygen, and due to having 5 water molecules, that gives me another 5 oxygen on the right-hand side. So on the right-hand side, I have a total of 13 oxygen. So that means on the left-hand side, I will also need a total of 13 oxygen. Since butanol has already given me 1 oxygen, that means I need 12 more on the left-hand side. So I will place a 6 in front of the O2. And now my combustion reaction is balanced. It is complete. It is good. So to recap, synthesis is when we have 2 or more formulas that then become 1 formula. And decomposition is the opposite. We have 1 formula that is breaking up into 2 or more formulas. Single displacement, we have something by itself that is reacting with a pair, forming something that's by itself and a pair. Double displacement, we have a pair and a pair reacting to form a pair and a pair. And the new one today was combustion, when we have an organic reacting with oxygen to form carbon dioxide and water. I want you to transfer this information onto your pink sheet. Once you have that complete, you can move on to the assignment. So please pause the video now, copy it down so it's accessible when you write your quiz. And that brings us to the end of this lesson. It's time to burn through that C12 assignment.